Yeah, I actually don't really have this down to 5 minutes yet. I have a couple hour-and-a-half versions, but I'm still working on the 5-minute version, so I'm just going to try to give you the gist of it impromptu. This is work that I've been doing over the past couple years. It's kind of on the cusp between research and development. I originally come from a background of applying neural networks to control theory and was going to work on robotics for a while, and ever since then I've wanted general purpose software to work more like that, where you kind of have this information feedback loop that guides what you're doing. So recently the thinking has become concrete enough to start to think of an implementation. So basically what I'm doing is I've got something like, imagine a Prolog predicate, but forget how Prolog does evaluation. Forget the control aspect of things entirely. So now what you have, and this could be some other mechanism of abstraction, it could be a function in another language, it could be a macro. Now it's just something that represents a joint space of relationships among the thing that it relates. I'm taking that and working out mechanisms for recursively composing statistical representations of the joint relationship space, and then there's an explicit query. Instead of a type system, you have an information system that keeps track of whatever the information you happen to have about these quantities that are related, or not even quantities, whatever they are. And then you have a planner that is trying to gain information about the query by taking these, working out adaptively in evaluation scheme. So probably it's going to look like a term rewriting system with an adaptive evaluation strategy instead of a fixed one at the highest level, and then there are ways to boil this down to things that are easy to optimize and map onto parallel hardware and so forth. So a couple interesting things happen in this setting. Like normally the halting problem is like you have to ensure a universal over all of the possible evaluation paths that you've written, but if you have adaptive evaluation, it just kind of becomes an existential thing where you just have to ensure that there's one way to make progress. And I think also there might be possibilities that resource management could become a lot simpler, because a lot of the state of the evaluation is kept in like a prioritized cache, and you can recompute things from where you are in the tree of evaluation steps. So potentially a lot of the storage management could happen implicitly as a result of that. And on the application side, again, like I think places where planning and optimization are done in a more ad hoc way are the ones I think that this could be a big improvement over what's currently done, like robotics, game AI, which is where a lot of the techniques come from as well. I also think there's interesting possibilities to pursue in like computer graphics, in that a kind of important sampling is already built into how the evaluation works, and that's kind of the basis of how you do ray tracing. And I'm actually working on another computer vision project, so I'm kind of thinking of how to have vision be the inverse of rendering in a stronger sense than it is conceptually. So anyway, as I said, there are a couple much longer talks about this, so that's about all I have to say right now, but if it sounds interesting to anyone, I'd love to talk more about it. Thanks.
Cool.